I saw this problem on YouTube the other day, and I was like, okay, let's give it a try. So the problem is sine of x plus cos of x equals to 2, and we need to find x. Okay, so let's consider this function y equals to sine of x plus cos of x. Now equals to 2, it doesn't have any real solution because the maximum value which can go is 1.414. Why? Because let's say if you want the maximum value of y, so we find like dy by dx and then equate it to 0. So what's our dy by dx? Equals to sine of derivative of sine x is minus cos x, cos x, and the derivative of sine x is cos x is minus sine x. And if we equate to 0, we get cos x equals to sine x. That means x equals to pi by 4 or 45 degrees. And if we put this value here, so y equals to sine pi by 4 plus cos pi by 4, which is 1 by root 2 plus 1 by root 2 equals to 2 by root 2, which is nothing but root 2, which is approximately 1.414. So maximum value of y is this 1.414. So this equation, sine of x plus cos of x equals to 2, does not have any real solution. No real solution. But we are mathematicians, so let's go into the imaginary plane. Okay, again, let's consider this equation is in pure arithmetics or simultaneous equation kind of term. So we have sine of x plus cos of x equals to 2. So squaring both sides, what do we get? Sine x plus cos x square equals to 2 square, which is nothing but 4. Okay, now if we simplify this, we get sine square x plus cos square x plus twice sine x into cos x equals to 4. We know this is 1, so 1 plus twice sine x into cos x equals to 4. So if we take this one this side, what do we have? Twice sine x into cos x equals to 3. Again, there is one more identity, which is sine of 2x equals to twice sine x into cos x. So let's put this here. What do we have? Sine of 2x equals to 3. And we can get a solution from this, like x equals to 1 by 2 sine inverse of 3. But we want to solve it further. Okay. So let's do this in imaginary plane. So what do we have? Sine of 2x equals to 3. Now you know the famous Euler's equation, which is e to the power I theta equals to cos theta plus I sine theta. This is one of the equations. And if we put e to, let's say, minus I theta, since cos of minus theta equals to cos theta and sine of minus theta equals to minus sine theta, so what will we get is cos theta minus I sine theta. And if we subtract these two equations, what do we have? E to the power I theta minus e to the power minus I theta equals to, cos will get cancelled, so we'll, and 1 minus minus plus, so it's like twice I sine theta. So we have this equation. Now again, if we simplify this further, so sine of theta will be 1 by twice I e to the power I theta minus e to the power minus I theta. Okay, and if we take the inverse of this one, so like 1 by I equals to minus I, so this is also the identity. So what will we have? Sine of theta equals to minus I by 2 e to the power I theta minus e to the power minus I theta. Okay, looks similar to this, right? What do we do now? Put, in our case, sine of 2x equals to 3. So we have sine of, let's say it's a sine of theta, and we have to find theta, which is nothing but 2x. So let's take this in mind and put this value 3 here. So what do we have then? 3 equals to minus I by 2 e to the power, now theta is equals to twice x. So e to the power twice xi minus e to the power minus twice xi. Now we have to simplify this equation and find a solution. For simplification purpose, let's put e to the power twice xi equals to t, just so that it's easy to work with. So then the equation will be 3 equals to minus I by 2 t minus, now e to the it's like t to the power minus 1 then, because this is t. So what do we have? 3 equals to minus I by 2 t minus 1 by t. And we further simplify this. What do we have? Minus I by 2t, so t square minus 1. Okay, and then again we take this one here, so 6t equals to minus I into t square, minus minus plus I. Now this became like a quadratic equation with t. So we solve this. So we rearrange this equation. So what do we get? Take one this side. So I t square plus 6t equals to I. So simplifying further. Again, 1 by I equals to minus I. So we divide both sides by I. So t square plus 6 by I t equals to 1 divided by I square. So again, and this is 1 by I is minus I. So it will become t square minus 6ti equals to 1. Okay. So the equation which we have is t square minus 6ti equals to 1. Now we need to solve this for t. Okay, so t square minus, so this can be written as 2 into t into 3i, and then we add on both sides the square of this, which is plus 9i square equals to 9i square plus 1. Okay, now I square equals to minus 1. Remember this. And this equation can be written as t is a, so a minus b whole square equals to a square minus twice ab into, oh sorry, plus b square. A here is t, so t minus b is thrice I square equals to, now I square is minus 1, so 9i square will be minus 9 plus 1. So t minus 3i square equals to minus 8. Again, it can be written as minus 8 square. Okay, so t minus 3i square equals to square root of minus 8 square. But again, this can be split up as minus, it's like minus 1 into 8, and then square root of minus 1 is I. So it will become this equation. So t minus 3i square equals to I into root 8 square. So now we have our solution. T equals to 3i. For simplicity, just take plus root 8 into I. Okay, so t equals to 3 plus root 8 is nothing but 2 root 2 I. Now we have t. But what is t? T is e to the power twice xi. Okay, so now let's put it back. E to the power twice xi equals to 3 plus 2 root 2 I. And take natural log of both sides. So what do we have? Log natural e to the power twice xi equals to ln of 3 plus 2 root 2 I. Now ln of e is 1, so twice xi equals to ln of 3 plus 2 root 2 I. Okay, and again take this side to this because we want x equals to 1 by twice I ln of 3 plus 2 root 2 I. Again, 1 upon I equals to minus I. So we take this up. So x equals to minus I by 2 ln of 3 plus 2 root 2 I. So this can be our solution for x in terms of all the known terms. Okay, we can further simplify this solution and into real and imaginary parts. That is basically the deal with the complex number z equals to a plus I b. Okay, let's try to do that. So here we can apply the logarithmic identity of ln a plus ln a into b is equals to ln a plus ln b. Our a here is this 3 plus 2 root 2 and b is nothing but I. So x equals to minus I by 2 ln of 3 plus 2 root 2 plus ln of I. Now again going back to the equation, e to the power I theta equals to cos theta plus I sin theta. If we put theta equals to pi by 2, then cos theta is 0 and sin theta is 1. So what do we get? E to the power I pi by 2 equals to 0 plus I. So it's nothing but I. And taking natural log of both sides, what do we get? Ln of e to the power I pi by 2 is equals to ln of I. This simplifies to I pi by 2 equals to ln I. Now we put this back here. What do we have? X equals to minus I by 2 ln of 3 plus 2 root 2 and ln of I is I pi by 2. Okay, and then we multiply internally. What do we have? X equals to minus I by 2 ln of 3 plus 2 root 2 minus I into I is I square divided by 2 into 2 is 4 pi. Okay, and I square is minus 1, so minus 1 into minus plus. So x will be finally pi by 4 minus I by 2 ln of 3 plus 2 root 2. So this is our solution this is the real part and this is the imaginary part. If the imaginary part is 0, then the maximum solution for x we get is pi by 4, which is nothing but our solution to this function, maximum value of y, which occurs at here at pi by 4. Realize how beautiful is this? Like, we have a real part in real world, and then there is the imaginary part in the imaginary. So Oshimaides.